Gray here, ready to do some Chapter 5 extra practice from statistics. Let's get right into it. Number 1 asks if the following are discrete or continuous. Part A says the number of problems in an assignment. Okay, well, you can count those and they are individually separate and distinct, so that is discrete. How about B, the time spent studying Chapter 4? Okay, well, any amount of time is possible for that along a scale, say from 0 up to, 100 hours or however much. Any possible answer could go in there within a certain, reasonable range, so that's continuous. They vary along a continuum. All right, number 2 has a survey asked to a sample of families. They asked how many TVs are in their households, and these graphics illustrate the results. We have both a table on the left and a histogram on the right-hand side. Now this asks, do the graphics above show a probability distribution? And to know that, we have to have 3 characteristics. X has to be numerical. Okay, number of TVs, 0, 1, 2, 3, 4. Those are numbers. All right, check. That one's okay. All the probabilities have to be between 0 and 1, and all of them are. So that's okay. Then all the probabilities should add up to 1. Well, let's double check that. We just add them all together. Don't forget the decimals. And it does add up to 1. Okay, so the answer is yes. These are both probability distributions. And they can be shown either way, in the table or the histogram. That's why they're both included on this slide. Number 3, if a household or family is selected at random, what's the probability that they have 3 televisions? Okay, let's write the notation. Probability X, number of televisions, equals 3. Equals. We can use either the table or the histogram for this. Either way that you do it, the probability is going to be 0.26. So just find that number in the table or in the histogram, and you have your answer and you're done. That's number 3. Number 4 says, what's the probability a household has an odd number of TVs? All right, so X is odd. Odd numbers are 1 and 3 in this case. 1 and 3 are the only odd numbers. Okay, so the probability of being odd would be the probability of a 1 or a 3. So X equals 1 or 3. We can add those together. Use the addition rule. Probability of 1, 0.11, or add. Probability of 3, 0.26. And you can't have exactly 1 and exactly 3 TVs at the same time, so we don't have to subtract anything with these. All right, we add those together, we get 0.37. And that's the final answer, number 4. Moving on, number 5 says probability a household has more than 2 TVs. All right, let's get the notation written. Probability X is greater than 2. The one's greater than 2, well, that would be 3 or 4. Okay, so let's add those together. That would be 0.26 plus 0.13. And when we add those together, we get 0.39. That's the answer for number 5. About number 6, probability that a household has 3 or fewer. So X is 3 or less than or equal to 3. That would be 3, 2, 1, or 0. So we can add all those together. Okay, that'd be 0.12 plus 0.11 plus 0.38 plus 0.26. And the answer is going to be 0.87. Now you may have noticed that if you're doing or you're finding the probabilities of 3 or less, then that's everything except the probability of 4. So I also could have done the complement rule, 1 minus 0.13, and gotten the same answer. Either way is perfectly fine. Use what makes sense to you. Now for number 7, is find the probability of at least one TV. So X is going to be 1 or greater. It's greater than or equal to 1. Okay, to do that, we can add up the probability of 1, 2, 3, and 4. Or we could do 1 minus the probability that X equals 0. Since those are all the numbers except 0. Let's do that as a shortcut. That'd be 1 minus 0.12, which is going to be 0.88. Again, if you wanted to, you could have added up all the probabilities from 1 to 4. Either way will give you the same answer for that one. Number 8. Number 8 says, what's the probability a household has at most 2 TVs? All right, at most 2. Go to the store and buy at most 2 loaves of bread. Well, 2 would be okay, but more than that is not. So that'd be less than or equal to 2. So we'll take the probability of 2, 1, and 0. And we get the answer, 0.61 for number 8. Number 9 says to find the mean, standard deviation, and variance of this distribution. Since we have a table or a histogram, we'll need to go to our list. To do that, press Stat and Enter. In list 1, I'm going to put the X values. In list 2, I'm going to put the probabilities. Don't forget the decimals. Once they're all in, go back to Stat, Calc, 1var Stats. Be sure to tell your calculator you're using list 1 and list 2. If you have a TI-83, you do L1, L2. If you have a TI-84 plus, list is L1, frequency list is L2. And when I hit enter, now I've got my answers. All right, let's write them down, and then we'll find the variance. Now this is a probability distribution, so I'll use the population symbols. Mu is going to be 2.2. We'll round to one place. All right, sigma is going to be 1.2. Now what about the variance? All right, to find the variance, you've got a couple of options. You can retype sigma and then square it, or you can use the symbols and square the symbol. Here's how to do that. Press vars, go to statistics, find sigma, and square it. Now we'll round that number to one place. We get 1.3, and that avoids round off error. So there's the mean, standard deviation, and variance of that distribution. Number 10 says, chosen at random, how many TVs would you expect one of the above households to own? Alright, expected value is the same as the mean. So, on average, you would expect 2.2. Now, can you own 2.2 TVs? No, not really, but this is on average, so it's okay that it's a decimal. Now for number 11. A basketball player who makes 58% of attempted free throws is asked to shoot 8 of them. Does this result in a binomial distribution? Remember, binomials have 4 characteristics. There's the fixed number of trials. Well, that would be the 8 free throws, so that's okay. All the trials are independent. Studies have shown that free throws are considered independent trials, so that's okay too. Alright, it's binomial, so there's 2 outcomes, success or failure. If you shoot a free throw, you either get it in the basket or you don't. So that's success and failure. And the probability of success is always the same. Well, for this basketball player, 58% is their probability of success. So yes, this would be considered binomial. We'll use the binomial distribution to answer the questions. Now, the previous questions, we had a table, so we just used the table. Now we'll use binom PDFs and CDFs. Number 12. What's the probability the player makes exactly 2 baskets? This is the probability that x equals 2. Alright, I'm going to write down the calculator command, binom PDF for this one. 8 trials, 0.58 success rate, 2 successes. Second vars, binom PDF, and there's my answer. We'll round it to 4 decimal places, 0.0517. Number 13. What's the probability the player makes exactly 1 or exactly 7 baskets? Well, since we have an OR, we'll use the addition rule. First, find binom PDF of exactly 1 and add that to binom PDF of exactly 7. Now the calculator is pretty smart. It can handle that all on one line as long as you make sure that the parentheses are closed as you go. Here's what I mean. Do second vars, binom PDF, close the parentheses if it's not already, then press plus, go back to second vars again, and do the other one. 7. Close it, enter, and there's the answer. If you don't want to do all that in one step, that's okay. Just make sure not to round until the very end. Number 14. Same setup. Probability the player makes at least 3 baskets. All right, at least 3 means 3 or more. So this is greater than or equal to 3. Go to the store and bring back at least 3, I don't know, cases of Dr. Enough. Greater than or equal to 3 has got to be what we're looking for. All right, the calculator will not count up, so we have to make it count up for us. You do that by using the complement rule, 1 minus binom CDF. Now let's think about what numbers need to go in here. Of course, the first 2 are what we're used to. The third number is the one we got to think about. We got 8 shots. 0, 1, 2, 3, 4, 5, 6, 7, 8. I want 3 and up. So I'm going to get rid of 2 and down. Okay, so 2 needs to be my biggest number when I subtract it out, because the 1 minus means I'm getting rid of those. To type that in, do the 1 minus first, then second bars, binom CDF. And there's the answer, 0.9366 for number 14. I'll move my calculator. Number 15. 15 says, what's the probability that the player will make less than 6? So x is less than 6. Okay, well, let's think about that one. You know, we don't have to list every single number. Let's just list the ones around 6. So ... 5, 6, 7, ... Less than 6 would be 5 and down. Okay, so for my calculator command, I need binom CDF 8.58 and 5. That'll add up 5, 4, 3, 2, 1, and 0's probabilities and give me the answer. And there I have it, 0.7250. Of course, you could have done a binom PDF of 0, 1, 2, 3, 4, and 5 and added all those answers together. You would have gotten the same thing. Number 16. Same setup. It says, what's the probability the player makes more than 5 baskets? Greater than 5. Well, the calculator won't count up, so I know this has got to be 1 minus binom CDF. First 2 numbers are always the same. The third one's the one I got to watch for. Let's think about it. I'll just list the numbers around 5. So 4, 5, and 6 and dots. More than 5 would be 6 and up. It wouldn't include 5. So I want to get rid of 5 and down. Okay, so that 5 is my third number. There's the answer. 0.2750. Number 17. What is the probability the player makes at most 7? Probability of at most 7. Would that include 7? Sure. Would that include 8? No. So that's less than or equal to 7. Okay, let's do some numbers here. 6, 7, and 8. Less than or equal to 7 would be everything from 7 down. Well, that means we can use binom CDF, 8.58 and 7. So we get 0.9872. That's the answer to that one. We also could have done 1 minus binom PDF with the probability of 8. Would have gotten the same answer. Number 18. So what's the probability the player makes at least one basket? So X could be 1. At least 1, well, that could be anything above it. So greater than or equal to 1. Okay, 0, 1, 2, ... Greater than or equal to 1 would be 1 and up. Okay, the calculator won't count up, so I have to work around it. 1 minus binom. We'd neither do PDF or CDF for this one, since the only one that we're leaving out is 0. But I'll do binom CDF to stay consistent. 8.58 and 0, because that's the one I don't want. And there's the answer, 0.9990. So it is a very, very, very high likelihood that this player will at least hit one of these 8 free throws out of 8. Number 19 says, well, it's the same setup. It says, what's the mean, standard deviation, and variance? How many baskets out of 8 should you expect the player to make on average? Okay. Remember, this is binomial. For binomial distributions, we have some formulas for the mean, standard deviation, and variance. Let's do the mean first. The mean for binomial is, no problem, n times p. All right, for this binomial distribution, n is the number of trials. That would be 8. So we have 8 times probability of success, 0.58. We have the answer. Since our number of successes are in the ones places, I'm going to round this to 1 decimal place. So 4.6 will be fine. So mu is about 4.6. I want to box that in so it'll be easier to find as we go. Now for the standard deviation, we have a formula for that as well. Standard deviation in a binomial is the square root of n times p times q, and q is just equal to 1 minus p. So for this problem, we already know what n is. That was 8. P is 0.58. And what about Q? Q is 1 minus 0.58, which is 0.42. When I type that in, I do second and square root. 8 times 0.58 times 0.42. Close the parentheses, and there's the answer. We'll round that to 1.4. So sigma is approximately 1.4. Put a little something around that. Box it in. All right, lastly, the variance. That's sigma squared. Okay, the formula for that is N times P times Q. Again, Q is 1 minus P. We've already got sigma in the calculator, so we could just square that number and get the answer. Here it is worked out the long way. 8 times 0.58 times 0.42, and you get the same thing either way. Rounded to 1.9 if we're rounding to the 1 decimal place. So sigma squared is 1.9. There's the mean, standard deviation, and variance. The last part says how many out of 8 should you expect the player to make on average? Well, expected value is the same as the mean, so we would expect 4.6 baskets on average out of 8. One question remains. Let's do it. Number 20 has the same setup. It says use the range rule of thumb. Yeah, that was the mean plus or minus 2 standard deviations. To find the minimum and maximum usual values. Then see if any numbers of baskets would be unusual for this player. And if so, well, tell us which ones. Number 20. I like to draw a number line for these, so I will. Range rule of thumb, the mean is in the middle. We're going to go 2 standard deviations above and make a fence. 2 standard deviations below and make a fence. My bracket looks weird there. Now, if only we knew the standard deviation and the mean. But wait, we do. We just did that number 19. There they are. So the mean here is 4.6, and sigma, standard deviation, was 1.4. It's okay that we're using the rounded one. Well, let's find 2 times sigma. Okay, well, that's 2 times 1.4. That's 2.8. Okay. We're going to go 2.8 above and below 4.6 and make some fence posts. And the handy dandy calculator will definitely help with that. The upper one, 4.6 plus 2.8 is 7.4. The lower one, 4.6 minus 2.8, gives me 1.8. So any values below 1.8 or above 7.4 would be considered unusual. Well, what numbers are we comparing this to? We're comparing this to the possible successes. 0, 1, 2, 3, 4, 5, 6, 7, and 8. Well, are any of those numbers, the possible success numbers, lower than 1.8? Well, yeah, 0 is. Are any of those numbers above 7.4? Well, yeah, 8 is. both of those are above. 8's going to be over here. 0's going to be down here. So 0, 8. Oh, there's one more. Below 1.8. 1 is below 1.8. Right there. 1's going to be right in there. So 0, 8, and 1. Almost missed that one. 0, 8, and 1 are all going to be unusual. Now, what does that mean? It means that if this player shoots 8 times, it would be highly unusual, statistically speaking, for him or her to only hit 8 of them, 1 of them, or none of them. So there's a very low probability that they'll hit exactly 0 baskets, or exactly 1 baskets, or exactly 8 baskets. Those are unusual.